Hi everyone, my name is Gabrielle, and today I'll be talking to you about my project as a Pawsey 2023 summer intern. So my project talks about the clean label backdoor attack needs optimization based trigger. So first of all, why we do this project? So we know that deep learning has doing an incredible jobs in recent year in computer vision tasks like image processing, image classification, autonomous vehicle, and many more. But it needs a really large data set for it to train to get a high accuracy. Because it needs a large data set, it leads to a gap where an attacker can poison the data set and attack the model. In this project, I'll be talking about the backdoor attack, which is one of the attacks that attack the deep learning model. So here's an example of a backdoor attack. For example, there's a stop sign, and we will predict the stop sign image as stop. But when we put a trigger on it, like a sticky notes, for example, okay, the vehicle will detect it as a go, not stop anymore. So how does the attack really works? So first of all, in the regular deep learning model, we will have a, for example, stop image, and we will label it as stop. But we try to poison it by if we put a trigger and we change the label into go. So in the training data, we change like every stop sign label that have a trigger into go, which is our target class. So the training data will associate the trigger into go. So in the end, every input that have a stop, that have a sticky notes on it, will have its label predicted as go. So why we do this? Because recent research shows that poisoning just 0.05 on a training data set can lead to 80% attack success rate, which is really great, because 0.05 in like 10,000 is just like 5 data that we poison. Then we come up with an idea. Does an attacker really need a clean label backdoor attack with an optimization based trigger? Does any other factors affecting this backdoor attack, or it is because of the poisoning? Because it's unlikely as well for us to know the training data of our victim, so we try to remove the poisoning part, which is only 5%, 0.05 poisoning, and we find out that the trigger itself, it acts as a universal adversarial perturbation, which is a noise that can affect the prediction of the model. And we achieve quite high performance on it, and we trying to improve the optimization of the trigger, in this case in satanics, and we get a 79 attack success rate, which is optimizing the trigger and not poisoning the training data. And we do all of this project methodology in satanics, because it's a lot faster using the supercomputer than using a local machine. And what did I learn through this project and throughout my intern? First of all, I learned how to use supercomputers, as I have never used supercomputer before. I learned so much in using supercomputer. I learned how to transfer data from local to supercomputer and how to submit jobs. I also learned to build a virtual environment there and to install like PyTorch to run my code. And I also learned about cybersecurity, coming up from a data analytics background. I do not know much about cybersecurity, but throughout this intern, I learned so much from my supervisor that is an expert in this industry. So I learned more about AI, more about the cyber in the AI as well, and also learn about research skills, how I can like do some research, to some literature review, and how to present it. I learn about more on the non-technical skills about time management, how I can set up like virtual deadlines to finish all of the project. Also learn about communication skills, how I can communicate with industry expert about to my supervisor, as well as present my ideas to general audience. And I also learned about presentation skills as well, through making the poster and weekly meeting as well. In my experience, I get to use high performance supercomputers like Saturnix. I also get to work with supervisors as well that are experts in my field. I get research skills and opportunity to present my findings as well in the poster presentation, and I get to meet fellow interns as well. That's all from me. Thank you very much.